All right, on this one, we're gonna quickly cover scalar product, also known as dot product. As you guys have seen, we've been making some videos for vector products. So in this one, we'll go through scalar products quickly. So key things to remember here, if you do a dot product of any of the perpendicular values, you will get 0. For example, I dot k or j dot k will be 0, and I dot j will also be 0. So we're only going to be dealing with the individual components that have the same vector directions. So in this case, if you're given two vectors, let's say A, which can be broken down into axi, ayj plus azk, and then if you have another vector b, bxi plus byj plus bzk. And if you're asked to do the dot product of these two vectors, you will pretty much multiply the values that are corresponding to each of them. So in this case, you do x, bx, and then here we do plus ay, by, and then here you get plus az, bz. And this is a scalar component. So it's a scalar. It doesn't have any direction. So it's only a magnitude. And another equivalent value of this is a dot b is also equivalent to the individual magnitude of vector a and vector b multiplied by the cosine of phi, which is the angle between the two vectors. So if you had vector a here and vector b here, and if there is angle phi between the two, so you do the dot product of the vectors, individual vectors, and then you also take, you could take the individual magnitude and multiply that by the cosine of the angle. They will be equivalent. So in this case, this left side of the component will be ax bx plus ay by plus az bz. And then for these ones here, for a, you take the magnitude of the square of each, ax ay square, and then az square, and then square root of, and then you take the square root of that. So this becomes a. And then for b, similarly, you will get bx square plus by square plus bz square. So once you get that, you can calculate the angle phi.